Okay, we'll now move on to the poster flash talks. We will have 6 talks in total, and they're really just short snippets to give you a flavor of what's out there in the poster presentations. And we won't do questions or any introductions in between. They're really just short snippets. So I would like to ask all the poster presenters to make sure they are somewhere close to the front so that we have a quick shift between those talks, and I won't be jumping up and down the stage, so they will pretty much move through by themselves. And once the poster talks are concluded, we'll then move to the a more in-depth discussion of the keynote talk. So with that, I'd like to move on to the first poster flash, which I believe is John Burley. Is John around? Okay, we will move on to the next one, which is Malia, who is here. Fantastic. Thank you very much. Great.
Thank you to the organizers for this opportunity to briefly share our work. We have been, for the past decade, working on a software package called PlantCV. It's open source and open development. And since this is the abiotic and biotic stress session, I'm giving you 2 examples, one biotic and one abiotic. This is a collaboration with some plant breeders. Plant breeders on the top left that were interested in quantification of wheat rust. So this is a naive Bayes classifier. We're calculating the probability that a pixel belongs into one class versus another class. We're using that exact same tool for an abiotic stress on the bottom there, where we're looking at the amount of damage caused by both a heat and a drought treatment. So one tool with a variety of applications. So there's a number of tools in the PlantCV ecosystem that can be hooked together for a number of applications. The package is used internationally, and so far there have been 139 publications that have utilized PlantCV out in the community within the methods sections of their papers. So if you would like to talk more about what's coming next, in particular, we're working on annotation tools as well as new geospatial tools. Please come find us during the meeting. I'm Malia, and then we also have Noah Thalgren and Katie Murphy, who are also very important to the PlantCV project and team.
Hello, good afternoon, everybody. I'm Reinier Gesto Borroto. I'm a postdoctoral fellow at Arkansas Bioscience Institute, and I'm more than glad to be here to explain the result that we obtained in collaboration with AgriGrow, a company from Missouri. We developed some experiments doing high-throughput phenotyping, also manual phenotyping, and we obtained some interesting results regarding vegetative and reproductive development, also about above and below ground biomass. Additionally, we obtained other significant results, and I will be more than happy to explain all of these results at my poster presentation this afternoon. My poster is number 22. I'm looking forward to see you there later. Thank you so much for your attention.
Sorry.
All right. Thank you for giving me the opportunity to speak. I'm Mike Kudenov, Professor of Electrical and Computer Engineering at NC State. I'm just talking today about, what polarization is useful for. see. All right, so spectroscopy, like hyperspectral, multispectral imaging, really looks at absorption. So we send light in, we lose some light due to the energy transitions in the molecules, and we use that as a fingerprint for sensing and classification. Polarization, on the other hand, really looks at structural characteristics, so anisotropy in the sample, fibers and things like that, especially on the order of 100 to 200 nanometers. So of course we'd have to use an SEM to image this, but we can use polarization metrics like retardance, attenuation, and depolarization to measure them without having to resolve them. So in the poster, we just talk about an experiment where we looked at 3 different corn plants with different levels of barrenness. So we ripped the ears off, and then 0 days barren, 16 days barren, 24 days barren. This is a metric called retardance. And so in the control, it has a generally low level. In the 24-day barren, it's relatively high. And then 16-day, we see that the upper canopy leaf, number 1 and 2, look more like the 24-day barren versus the control, which looks more like the healthy sample. So in this case, we're seeing kind of a form of early detection in the retardance value. This is retardance at the top. This is the cell phone image of the control, the 16-day or the 24-day. Of course, here you can see very visible symptoms. 16-day really just has this elevated retardance, but RGB-wise, it looks pretty similar to the control. So happy to talk more about it at my poster. Thank you.
Hello everyone, my name is Jung-Hyun Park from Seoul National University. Today I would like to talk about my research on assessment of a cucumber distribution using drone imagery. Okay. Cucumber is a rapidly spreading invasive weed that overtake other vegetation. It makes difficult to manage, so it spread to decline of biodiversity, as indicated decreased Simpson diversity index. So we use drone imagery to detect and assess the distribution of a cucumber to address this problem. We select the experimental site along the Anson River in Korea, and we using a DJI Pentapo Pro, we captured high resolution images and mosaic them together using Pixel software, and then processing, we analyze the images to identify and segment the area covered by the cucumber. Our results show that by using the CIA LAB color space, we could separate the cucumber from the background vegetation. And RGB analysis show that the cucumber had a higher green value, so it making it easy to segment. And when we compare the ground truth data with the drone imagery, we found a strong relationship. So it allowing us to effectively monitor how the cucumber has spread across the area over time. In summary, our study effectively mapped the spread of the cucumber using drone imagery. We found that the cucumber had a much higher green value than the background vegetation, and the distribution from the drone imagery matched closely with ground truth data. This shows that drone imagery is a useful tool for monitoring and assessing the spread of the cucumber. I would like to acknowledge the guidance and support of Professor Do-Sung Kim and the contribution of our team members. Thank you so much.
Hi everyone, my name is Ronald Katamba. This is our project which we are working on. It's already in place and it's working. So far we are focusing on livestock and crop in monitoring and also disease detection. we have so far rolled out to, we have almost 75,000 farmers who are already enrolled on this platform, and we have published our paper, about 2 papers for about LoRaWAN and drone technology. And we have a paper we've already published. We so far rolled out a pilot in New York and Iowa about LoRaWAN and drone technology. And if you want to make sure you get more about what we're doing, please, our paper is on number 53. So you can come and we have an interaction about how drone technology has done a great thing with the data we're collecting and everything. Thank you so much.